Hi, I'm Pat McCormack with the Riverhawk Company. Today I'm going to talk to you about some technology we have offered to industry for several years now, but is becoming more popular with its latest release in API 671. This technology is a clamp device that goes on hubs. So for your shaft end connections, this technology will have significant benefits that we will go over today. What this technology replaces is on your turbo machinery applications, if you had a keyed fit or if you had a tapered interference fit shaft, a straight shaft that you put on with heat, this technology is a clamping device that will replace all of those. So no longer do you need to use the keyed shaft. You don't need to use all the installation tools to install your hydraulic fitted hub or heat for different types of hubs. We have a technology that we're offering that is a clamp device. The concept is a hydraulic clamp that goes on the OD of the hub, will squeeze the hub, so you create that interference fit on the shaft, which you originally did with your tapered interference fit, or you were transmitting torque with your keyed shaft. This concept squeezes the hub OD. The activation is done hydraulically, which we'll demonstrate here in a few moments, and held mechanically. So the hydraulic pressure allows you to put a tremendous amount of squeeze, giving you a good interference fit to transmit the torque, but then it's held mechanically by the retention screws that we'll go over during the demonstration. The components. Basically, there are three components. There's a piston, a cylinder, and a collet. When the piston and cylinder get hydraulic pressure, the hydraulic pressure is making the piston and cylinder come apart, squeezing on that collet, squeezing the hub to the shaft, giving you that interference fit. There are retention screws and retraction screws that I'll show in the video of the demonstration that do the mechanical locking and also aid in the removal of the clamp technology. What you see on your screen is a cutaway image of the clamp technology. Using hydraulic pressure, the hydraulics will go between the cylinder and the piston, which pushes the cylinder and the piston apart, going up on the wedges of the collet, creating a clamping force on the hub. That clamping force creates your interference fit between the hub and the shaft, just as you would have done originally with your traditional shaft end connections. This will greatly simplify your shaft end connections. No keyways, no splines, no more hydraulic taper interference fit required. The clamp will go on the hub OD and create those interference fits. It also can reduce shaft diameter because you can put significant more clamping force with the clamp technology on your hub to shaft juncture. You can now make a shaft smaller, you can make it straight, which will reduce your overhung moments. We could take existing shafts that were tapered, convert them to a straight shaft that also will allow you infinite axial adjustment, no longer requiring shimming of the coupling once you install the hub. It's also balanced in the stressed state, which is impossible with your traditional keyed hub or your tapered bore interference fit hub. Cost benefits. This technology will greatly help reduce scored hubs and shaft surfaces, because no longer do you have the interference fit where you're using dilation pressure to expand the hub, the pusher tool to push the hub up on the shaft, or using heat to dilate the hub and push it up on the shaft. This hub clamp technology goes on with a loose fit into its position. You activate the clamp and create that interference fit. This will greatly eliminate scored hubs and shafts. Reduced tooling costs is one of the big benefits of this technology. No hydraulic pusher is required, no ring and plug gauges or laps required. field service of a straight shaft is significantly easier. No exposed seal surfaces. When you have your seals and your tapered bore hubs, the seal can get damaged putting it on and then it will be leaking. The seals of the clamp technology are not exposed in any manner, so they last a very long time. And it only requires a medium pressure pump versus high pressure to dilate a hub. You get pressures upwards of 20, 30,000 psi. You would never go above 8, maybe 10,000 max psi in this clamp technology. Now we're going to go over installation steps to show just how easy this technology is to use. We have a demonstration that we travel around showing everybody, but we're also going to go out into the lab and do a real live application with real parts. The first step in the installation of this technology is to inspect the hub bore as well as your shaft end. You want to make sure that they have the correct taper. We can make these with a CMM to get the correct taper. The gauges, the taper gauges, really are not required because you don't need the very precise contact with this clamp technology as you would want with your traditional tapered bore hydraulic fitted hub. Once you make sure that the tapers are correct, you want to clean the shaft and the hub along with light oil. And I say that because it's still a very precise precision fit. It's going to go on, slide on in place. You don't want to have lint, dirt, sand, grit, anything between the two surfaces. So taking a light oil and putting it on your hub ID and the shaft will aid you in installing it. So after you took a look at that, the hub, shaft, and bores are clean. You're going to slide the hub clamp assembly on the shaft end. When you slide the hub clamp assembly on, you want to line up your hydraulic fittings. It's hard to do in our demonstration because I don't have the access, but you're going to put your fittings at 6 and 12 o'clock because we're going to put hydraulic pressure in and bleed the hydraulics out. For this demonstration, I put it here for ease of access for us to do, but when I get into the lab and show the real application, we'll stress that more. So simply when you install the hub clamp assembly, you're going to apply hydraulic pressure. So with the hub in place, you're going to set your initial gap. And what the initial gap does is right now the hub is loose on the shaft. Now you can do this in a couple ways. When you first put your hydraulic pressure on, if it's a small hub, you can move the hub like this, and when it first grips the shaft, that's your initial gap setting. We're trying to set this initial gap so we can tell the total gap that we're going to set, which I'll get into in a moment. An alternative way on a large hub, you couldn't move it so much, especially on a tapered hub. It may have what's called a taper lock. When you put it on, it sticks on there. What you're going to do is just watch the pressure. So when the hub is on there, you still want to set this initial gap. You'll start pumping it up. You'll see I'm pumping. There's no pressure building up because it's still loose on the shaft. So you're not building any pressure. But when you install it, as soon as you'll feel it in the pump, but you'll also see your pressure gauge coming up. That's going to be your zero start, your initial gap position. What you want to do is measure this initial gap. You can do this in various ways. A pair of calipers, gauge pins. You want to take this initial gap, record the initial gap, because on the drawing, we're going to specify a gap that this clamp needs to be at to give you the exact interference fit that you need to transmit the torque for your application. Every one of these that we manufacture and sell has an installation manual. The back of the installation manual has a little data sheet that you can record this information for later use, because it will also aid in removal of this technology. So we measured the initial gap. I'm not doing it here. We will do it in the lab on the real application. This is just showing the basic concepts of this technology. So once we measured the initial gap, we're going to look at the drawing to to see what the gap needs to be. We're going to add our initial gap to that, and then we'll set that again with gauge pins. So if I was going to do this properly, we'll keep pumping it up. As we're pumping it up, you can see the pressure coming up. I'm not really worried about the pressure. There's a max pressure that we'll specify do not exceed, but you're going to be looking at this gap with a gauge pin or a pair of calipers to set that total gap that you recorded. Once you get that total gap recorded, there's going to be retention bolts. These retention bolts hold this clamp mechanically open, so you don't maintain the hydraulic pressure. If you get 6,000 to 7,000 hydraulic PSI in here, you want to hold it mechanically so you don't have to worry about losing it. So you adjust the retention bolts, just snug. They don't have to be cranked down tight. Once you have the retention bolts snugged down, you can release the hydraulic pressure. Releasing the hydraulic pressure, you can see now that the clamp, there is no hydraulics in it. It's held mechanically, hydraulically activated, mechanically held in place. That is the complete installation. What you'll do, and you'll see in the lab when we do it for real, you would take the hydraulic fitting off and then let the hydraulic fluid bleed out, put the hydraulic plugs back in, and now you're ready to operate. That's the installation process. Now that we've gone over the installation process, let's take a quick look at the removal process. You should have recorded the information as I spoke of in the installation. That information will be very useful in the removal or aiding in the removal. So simply when you want to remove your hub with the clamp technology, you're going to put the hydraulics on. If you recorded the total gap and the initial pressure, that will be useful information now in removing the hub, because you can watch that pressure as you bring it up. The key, the goal, what you're trying to do is remove the load on your retention bolts. Right now, if you tried to remove these retention bolts, you wouldn't be able to, because it's mechanically holding the clamp in its clamped position. As you bring up the hydraulic pressure, as I said, if you recorded it on your installation, you could bring it up close to that pressure, and then you're going to keep checking your retention bolts to see. You'll be able to loosen them. Right now you can't loosen them because there's so much load on them. Once I got close to the installation pressure, you'll see now that I can back off the retention bolts, making sure that you have them all backed off. Now you can release the hydraulics. When you release the hydraulics, you can see that gap close up, and now that hub is ready to be removed. The different design variations that we have for this technology allow it to be used on many different shaft end connections. There's the straight shaft, there's the tapered hydraulic shaft, there's the keyed tapered shafts and keyed straight shafts, all of which can be retrofit with this technology. That concludes our demonstration to give you an overview of this technology. What we're going to do now is go out into our lab and show a real-world application, actual hub, actual shaft, installation, and clamp, to give you a better idea of the installation process as well as removal process. Hi, I'm Pat McCormack with the Riverhawk Company. Today we're going to go over an actual installation with our clamp technology, sometimes referred to as a shrink disc. This is a real application, a real clamp. The diameters, everything are an actual application from out in the field. The first thing you want to do when you receive our hub clamp assembly is to inspect it. You want to inspect it for the proper taper so the shaft and hub have the proper fit. You're going to stone any burrs off of your bore or your shaft end, which we're really not doing today because this is a lab environment. I've looked at this taper. We will make the taper of the hub to a gauge if you have one, or we can do it by CMM. But you just want to confirm that it is the right diameter, the right taper, the right size before putting it in your application. That's the first step to do, the inspection of your taper and your shaft. Once you've confirmed that, the next thing you want to do is clean the taper of the bore and your shaft. Cleanliness is extremely important. No matter if you're using a traditional tapered bore hub installation or our clamp technology, cleanliness is the utmost importance. We're going to ship the hub assembly, clamp assembly, with a Cosmoline coating on this bore in here. It'll be a kind of a yellowish, sticky type of coating that has to be removed. In our installation manual, which we provide with every hub clamp combination, we've provided an installation manual that clearly defines how to clean the bore. We recommend acetone, WD-40 will penetrate nicely, but you want to really make sure when you're cleaning it to get all of that coating off. That will affect your installation. So I'm really trying to stress cleanliness, very important. So this has been cleaned. I was just showing quick a lint-free cloth, acetone, WD-40 to clean the bore nicely. Once the bore has been cleaned and your shaft has been cleaned, what you're going to do is put a light oil on the surfaces, on your shaft surface and your hub bore surface. We recommend doing that with a rubber glove on if you don't want to get your hands that oily, or just your hand. I don't want you to use a cloth because then you could get the particles, the lint, and all that into the bore. I'm really emphasizing cleanliness, as you can see. So with a light coating of oil on your bore and on the shaft end, you're ready to mount the assembly. When you receive the clamp hub assembly, it will be just as you see here today. However, there are times when you want to remove the clamp assembly from your hub assembly. That's fine to do, it can be done, but I just want to go over the actual steps of installing it. So if your clamp was not on the hub, you really want to pay close attention to match mark lines. Because this is a lab environment, we don't have the match mark lines, but they'll have clearly a match mark on the clamp assembly and the hub. Those match marks are where this assembly was balanced in. So when you're going to install it, you want to make sure that the match marks are lined up, because if they're not, you're going to impose an imbalance on this assembly. Very simple to do. The lines will be very distinctive to show. It shows it on the drawing to line up the match marks. So the key in putting the clamp back on your hub is lining up those match marks. The other thing you want to use caution with is if you try to remove the clamp assembly or install the clamp assembly, you don't want to push on the clamp. Pushing on the body of the clamp right here really is activating the clamp on the collet. The collet has a taper to it, so as you push on the outer assembly of the clamp, you're actually putting a pressure squeezing onto the hub. It makes it very difficult to get on. You want to push on the collet. Right here is the collet of the clamp, so you can hit here with a hammer, you can tap around here on the collet to get it to go down onto the hub. It would be very difficult if you just pushed on it right here because you're activating the collet. So the key thing to point out to everybody on an installation, if you're installing the clamp assembly on your hub, you want to push on the collet. If it's tight, we actually send retraction bolts with the clamp. These retraction bolts will force the clamp closed if it's not fully closed. That allows you more room, easier access to put it on. And I can show that real quick. Right now you can see how it's tight on the hub. That's because there's a little bit of opening still in the clamp. So if you take your retraction bolts, turn down the clamp, all you're doing is closing this gap here completely, and in closing that gap, you'll see the hub moves on the clamp. The clamp moves on the hub. This is what you want to do to line up those match marks. If those match marks are on here, you couldn't turn it before, you want to take your retraction bolts, tighten down the clamp, line up those match marks. Once you've done that, you take out your retraction bolts, You can put them all in. I've only put a few in, a couple in here to demonstrate this real quick, but you see the holes around here for the retraction bolts that allow you to do that. Once you do that, what you want to make sure of is that you put a little bit of pressure back on the clamp so it doesn't fall off. When you go to install this, if I picked it up now, the clamp assembly could fall off the hub. So I'll show you what you want to do is snug the clamp down onto the shaft or onto the hub. So these are our retention bolts. Once we activate this clamp, these bolts that I'm snugging down right here are what's going to hold this clamp in its loaded position. So it's hydraulically activated, but mechanically held in place. So all I'm doing right now is bringing these down, because as you saw, I showed you, it was loose on there. Now if you watch, I'll snug these, just a few of them. And now it's on the hub very tightly. So when I pick this up with the crane, you don't pick the hub up and there goes your clamp falling on the floor. So snug them down. The caution to use here is if you snug these too much, it may be difficult for you to get it onto your shaft. So being a tapered bore, it shouldn't be an issue, but I'm stressing that you don't want to just crank these down super tight. Just snug so your clamp doesn't move. You got your match marks lined up, the clamp is snug, you're ready to install. Another thing I'll stress real quick is we've done this in the lab environment many times. Some of us have done this installation many times, but I highly recommend following the installation manual because it's very easy to skip a step, miss a step. If I didn't, say, snug down these retention bolts, I'd have picked this hub up, the clamp would have fallen off, and I'd be, oh, I forgot to do that. So our installation manual gives step-by-step procedures that show everything that I'm showing today, and I'm recommending to follow that so you don't miss a step and do something wrong. So now that the clamp has been seated on the hub, match marks lined up, we're ready to do the actual installation. So this is entirely too heavy for me. If this is a small one, you certainly could just pick it up and put it on your shaft end. Larger ones, we have lifting ports to use your overhead crane. Okay, now that we've used the crane to get the hub into position, we're ready to install the hub onto the shaft end. So, using the crane, usually this would be a two-person job, but I kind of positioned the crane so it's very easily put onto the shaft end. Being a tapered bore, you want to be careful when you first put the hub on. If you push this on fast, you're going to get what's called a taper lock, and it's going to be stuck in place. It's okay, it's not a problem, but on the smaller hubs, it's easy to put it on because it's so light. You get a very big hub, and you're using a lot more of the crane. You're going to have two people, a person controlling the crane and a person guiding the shaft on. This isn't that big, so I was able to use the crane, get it pretty lined up, and just push it in place. What you want to do on a smaller hub, it's nice to put the hub on once you get it in place. So you can turn the hub on smaller ones. You get a very large hub, you're going to put it on, you're going to see that it gets stuck on what we call taper lock. Because the tapers are so close, so accurate, it's very quick to get it stuck in place. It's okay because that's where you're going to start clamping. There's really two options when you're doing the clamping of the hub clamp combination. On a smaller hub, when you put it on, you want to turn it back and forth until you get the initial grip. I'll show you that when we hook up the pump. On a larger hub, you're going to push it on. You won't be able to do that, but you're going to feel the pressure in the pump. And we'll go over that again when I get there. The thing to point out when you first put your hub on is you want to rotate the hub. You can take the hoist right off now. You can get the hoist out of the way. you're done using that for the time being. Okay, with your hoist out of the way, I would highly recommend putting on your shaft end nut so you don't have to worry about your hub coming off the taper falling on somebody's feet. So take your shaft nut, put it on just snug. You're not going to tighten it down. We don't have it clamped in position yet. You want to put your hydraulic ports at 6 and 12 o'clock. So you're going to turn the hub. On a larger hub, I would say line them up before you put it on because it may go on and give you that taper lock that I was talking about. On a smaller hub, you should be able to position the hub nicely as I just did. The reason you put the ports at 6 and 12 is because we want to bleed out the hydraulic oil. You're going to hook your hydraulic hose to the bottom, open up your top bleed port, and bleed out hydraulic fluid, which we have to do. So take your top, your 12 o'clock plug out, hook up your hydraulics. You got to take the fitting out. Again, I would recommend the nut, the shaft end nut, so you got to worry about your hub falling off. Put your hydraulic fittings on, removed the plugs, put the hydraulic fitting on, snug down the fitting, and hook up your hydraulic hose. Okay, with the hydraulics all hooked up, we're now going to bleed hydraulic oil, get the air out of the clamp so we can build up pressure. It's not crucial to get the air out. It's a recommended step because the air is obviously compressible and it'll make it spongy. So you want to bleed it out. It ain't got to be perfect. You want to bleed it out enough. So hook up your hydraulics. You can position the pump so you can see the oil coming out. Again, with two people, it'd be a little bit easier. Somebody can watch it for you without making a total mess. Put your plug back in when you get the hydraulic oil bled out. Put your plug back in. Wipe up your mess if you made one like I did. Okay, now with your hydraulics hooked up, the hub is in position. What you want to do is set the initial gap. The initial gap is where this hub grips onto the shaft. As I said, on smaller hubs, you can rotate it slightly like this, and you'll feel it connect in. Right there is where the hub actually gripped the shaft, and I can no longer move it. The other way of doing this is when you put the big hub on and it gets the taper lock and it's stuck on, you can feel significant pressure in your pump. I was pumping it up. I was moving it to see when it was going to grip in, but the very moment I felt pressure in the pump is when it gripped the shaft. On a large hub, that's just what you're going to do. You're going to watch your pressure gauge. You'll come up to 100, 200 psi, and that's when you know that the clamp is gripping the shaft. Smaller hub, you can move it. Larger one, watch your pressure. Once you do that, you want to use gauge pins or a caliper, something to measure this gap. We need to know what this initial gap is, because on the drawing, we're going to specify the actual installed gap. So the installed gap is your initial gap plus that installed gap. There's a total gap at the end that you're going to record. So in the instruction manual, you'll have a spot a data sheet at the back of the instruction manual to record the initial gap. So you're going to take a gauge pin and you're going to measure, or a caliper, and measure that initial gap. When you get that initial gap setting using different gauge pins or your caliper, you're going to record it on that data sheet. What you're going to do with that value is add it to the installed gap on the drawing. That'll give you the accurate clamping force to transmit the torque that you need to transmit for this application. So, I don't have the data sheet, but you would record that installed gap, record the gap on the drawing. Now that's the total gap that you're going to pressurize this to. There's also an estimated pressure on the drawing that you'll see that gives you a general idea what pressure you're going to go to achieve that interference value that you need. We'll also do it with the gauge pin. The gauge pin is going to show us that installed gap that was on the drawing. So, again, using your hydraulic pump, you're gradually bringing up your hydraulic pressure. A couple people doing this would make it a little bit easier. You'll see the clamp starting to open up. Again, you're going to be checking it for that gap. Okay, so using your gauge pin or caliper, you're going to keep pumping up your pressure. You'll see the pressure building up. Should be close to the pressure specified on the drawing, but you really want to watch that gap. Once you get the gap set with your gauge pin that I'm using, what you're going to do now is snug down the retention bolts. The retention bolts are what's going to hold the clamp in its activated position. So hydraulics are not used only to activate it, and it's mechanically held in place. You want to make sure that you get all of the retention bolts snugged down. I just did it by hand quick, put the ratchet on there, and just, you can use an Allen wrench. A quick snug of each one. You don't have to crank these tight, you just want to snug them all down. But you want to go around and check each one. Make sure that you have them tight. Once you have snugged them all down, you can release the hydraulic pressure. Releasing the hydraulic pressure, now you can see that this hub is tight onto the shaft. You have now the interference fit that you would have traditionally had with your hydraulic tapered bore hub done by the clamping mechanism. So what you want to do is check the gap to ensure that you have not, it may have relaxed some, so you're going to take your gauge pin and put it in and make sure that you have the correct gap. Looking at the drawing, looking at the initial gap that you recorded on your data sheet, that will confirm that you have the clamping force to transmit the torque for this application. Once you've done that, you can take off the hydraulics and remove the hydraulic fittings and your top port and drain out the hydraulic fluid. Once the hydraulic fluid is drained out, you put your plugs back in and you're now ready to operate. And that is the installation of the Riverhawk clamp technology. Now for the removal process. The removal of the hydraulic clamp assembly can be more easily done if you recorded the data of installation. Why I say that is because on the installation data sheet, there's a spot for the actual pressure that you used and the gap that you installed it at. That pressure will give you some idea where you're going to have to go in the removal process, because what we want to do is pressurize this clamp to relieve the load on the retention bolts so we can release the clamp. you'll see if you tried to remove the retention bolts, these are very tight because they're holding the whole load of the clamp. I can't budge these. But once I get the hydraulic pressure back in there, you'll see that the retention bolts are very easy to unload. So that pressure that you installed that you recorded, will help you in the installation. So the first thing you want to do in removal is, again, bleed the air out. So you're going to put your hydraulic fitting on, hook up your hydraulics, take your top bleed port out, and pump up the hydraulics to bleed out the hydraulic fluid in the clamp. With that done, you snug down your bleed port and you're ready to activate the clamp for removal. I'm actually going to leave the socket right here because you're going to see when I get to about the installation pressure, it's going to fall off by itself. Position it so it's there. So again, I recorded the hydraulic pressure. With the hydraulics hooked up, we'll start bringing up the pressure. And it's that easy when you relieve those retention bolts that you can loosen them all up now. So I brought the hydraulic pressure up right to about what the installation pressure was, and now you should be able to go around and remove, back off, I should say, all of the retention bolts. If they're tight, some of them are still tight, you can put a little bit more pressure in them. You want to be careful you don't go past the max gap opening of the clamp. You shouldn't have to exceed the pressure beyond what you installed it at, very little, but the retention bolts should thread off very easily. The big thing to point out in removing the retention bolt is that you actually back all of them off. If you leave just one of them, you're still going to be holding that clamp open and it won't release. So go around, remove the retention bolts off the clamp. So as I mentioned, you want to make sure you have all the retention bolts. So it's very good to go around. I was going to miss one myself. You want to do a good visual check all the way around the clamp to ensure all of the retention bolts are backed off. Once you've done that, you're now ready to release the hydraulics. Releasing the hydraulics should eliminate the interference fit of this hub to shaft juncture. So I released the hydraulics. Most cases you will release the hydraulics and be able to spin the hub. If you can't, the hub might be slightly stuck. I'd back off the shaft end nut. You can bang on it a little bit with a dead blow hammer, I would suggest. Some of the larger hubs, as I said, you might have that taper lock. It won't loosen up or relieve itself that easily. What we have in the end, when you take the shaft end nut right off, and the end of our hubs, there are puller screws, puller holes. So if the hub is stuck on, you want to make sure that the clamp is fully released. If it doesn't release the hub, like I'm showing here, the hub is now loose on the shaft, there are puller holes where you can take a puller tool, thread it into your hub, and then push against the shaft, and then that'll pull off the hub because there is no interference. All you're doing is the taper lock. One thing to point out is the retraction bolts. There's retraction bolts to make sure that the clamp is fully closed. When you release the hydraulics, you saw this gap close up. If it's still stuck on, you can take your retraction bolts, thread them into your clamp, and make sure that it is fully closed. The retraction bolts are just going between the two and squeezing it closed. Because if there's still a little bit of opening in your clamp, that may be what's causing you to be stuck on. So before beating it with a hammer, before using your puller, put your retraction bolts in, snug them down, and see the clamp will then spin on the hub. So if your hub was on the taper lock, kind of stuck, you would see then that the clamp would spin on the hub. Once you have released the clamp, you can remove the hydraulics, hook up your crane, an area of caution to point out to everybody, as I just mentioned, using your retraction bolts. If you have the clamp loose on the hub now because you used the retraction bolts to release your hub being stuck on, you want to use a lot of caution that the clamp is snug to the hub. Because right now, if I lifted this up and the clamp was loose on the hub, if you could spin the two, it would fall off. Your hub would fall off of your clamp. So if you did use your retraction bolts and now you have the hub loose on the shaft with your crane hooked up, you can check the clamp. See how my clamp is spinning on the hub? There's danger there that this hub could fall off the clamp. So to do this real quick, you would take your retention bolts, just snug the retention bolts back down, because that's going to put a load on the clamp, so it'll no longer spin on the hub. So now you see how the clamp is tight? The clamp is turning the whole hub and assembly. You want to use caution there, because if you don't do that, your clamp will, you're holding onto the clamp, it could slide off. So, with that being done, and there you have it, the installation and removal of the Riverhawk's hydraulic clamp technology. So that concludes our installation and removal process. I think what you can do watching this video is a good time study to show how quick this installation was, how quick this removal was, because you can see I was talking through the video, which even adds time to it, but it's a much quicker process than you would use with your keyed hub using heat, your interference tapered bore hub using both pumps with your pushers, the plug gauges and all that stuff. It shows just how easy this technology is and can be used. So, I'm Pat McCormack with the Riverhawk Company. Thank you for watching.